and also share my screen. Okay, can you see the COVID-19 presentation? Thank you so much, Curtis. Thank you, everyone. So, as per university regulation, we do have to share this in the beginning of every lecture and lab session. So, as you all know, COVID has literally made our lives difficult, but again, there are safety regulations that we do have to follow, especially when we are at the lab, in the physical lab on campus. So I wouldn't go through each and every line of it, but as you all know that we have to follow some safety procedure. Let me see if, okay. So in case, first of all, if you do end up like showing any COVID symptom, please do not come to the lab in order to protect others and yourself as well on campus. And do often do a regular check and test so that you are completely aware whether you are COVID free. Now, in case you do end up getting COVID symptom, you do go for the PCR test to confirm. But depending on the result, if the test result come positive, do notify the university so that we can take precaution and can stop the spread of the virus. When you are on campus, especially in the lab, please do use face coverings so that like you can protect yourself and others around you. And as I've already mentioned, please do get tested at least twice a week and do like inform about your testing to the COVID department of the university and the school office in case you do find a positive result. Now, vaccination clinic is also provided on campus, so you can read through this and you can also like get more information from the link here on vaccination if you need it. Again, I've already covered this and I don't want to bore you with these details, but again, do keep yourself safe and also keep others safe around you. Now, let me stop sharing this. So first thing, before we go into the lecture, of course, you can use the chat, but if you have specific question, it's better to use the Q&A section of Zoom. So it's easier for me and the GLA and GTA who will be joining later in the lectures. So it's easier for us to track the question and answer it appropriately. Does that make sense? Thank you so much for confirming, Stefan, Curtis, Dragus. Okay, let me now move into the fun part, the actual lecture. So, can everyone see the slide and the presentation on CE305? Thank you. Okay. Welcome once again to CE305, languages and compilers, or I also call it the module where you learn how to build your own compiler. So let's get to know about me, your module supervisor. So who am I? I am Somdip De. I've worked in the industry for over 13 years as a software engineer, research engineer, team lead, and scientist. And I even built technologies for Microsoft and Samsung. I was also fortunate enough to publish more than 70 intellectual properties over the years. And currently my work is used by billions of people around the world, including you. I have been also involved in developing the ISO standard on systems and software engineering of websites, which is the standard you can also Google, called ISO 23026. Now, I have also pioneered a new technique to bridge the gap between natural language processing and computer vision-based machine learning, which enables the machine or your computing system to understand programming language using computer vision. Now, in case you want to learn more about my projects that I'm currently working on, you can Google Somdip De. I know it sounds cliche, but Google is our best friend in this day of age and of information. And in case you find something interesting or you want to collaborate on a project, I'm always open for it. So do get in touch and we can discuss further on a specific project. Now, today's lecture is going to be an overview and introduction to the module itself, CE305. So moving on, do keep in mind that every week we have lectures and labs. So the lecture is on Tuesday for 2 hours, and the lab is on Monday for 2 hours as well. And this will run through the academic week till 25. The labs will start from next week though. Excuse me. Now, this is the important bit because this is how you pass the module. This is the assessment. Before I mention the assessment, there is a question. Let me see. Is there a reason for scoring low on the SAMT? Yes. So last year, we actually had the lecturer who was primary teaching this module. He retired, unfortunately, in the middle of the module while it's being taught. So there were handover and there were many confusion. But this year, I am in charge from the beginning. So no handover, no confusion. And in case you have any question, my doors are always open. So do ask me any question and I would love to help you as much as possible in my capacity. So I will mark this question. Okay, should we be afraid of the assignment? That's another question. No, you should not be. First of all, we give you all the resources that it actually makes it easier for you to tackle the assignment. We also give you a breakdown of how to tackle the assignment. And I will be going through them shortly, so please do not be afraid of it. But that being said, we have generally found out that you do need to have good programming skill and understanding of how to write code in Java, especially how to write modular programs. So if you are comfortable with Java, then you shouldn't find it difficult at all. So in case you do not find yourself comfortable in coding in Java, please do take some additional courses on the side to improve your skill on the Java programming, if that makes sense. And that would help you greatly. Let me mark this question as well. Okay, another question is, I could not find a resource on Udemy or any practical books about compilers. So if we need additional help, how can we find it? Don't worry, we will cover all these stuff in today's lecture. So as we go along, you will get the understanding of what are the resources that are available for you and how you can tackle them. So another question, wow, we are getting a lot of questions. Good. I really like when people like participate in the Q&A and chat. Thank you so much, guys. So can you recommend some courses we can take? Of course, this module, this is what you can take in order to like pass through the exam and the assessment as well. You do not need more than this. Yes, we cannot cover everything given the limited amount of time. So all the resources that you will need separately in order to understand or grasp a concept, you will also be provided as well. Hope that makes sense. I will mark these questions as answered live already. Okay, do you agree with the notion that ability to write compilers give an edge to the programmer? Yes, absolutely. Especially because, so, okay, it depends on your aspiration as well. Now, I have worked at Microsoft and Samsung. I did go for Google interview, but then I left the interview halfway because Microsoft and Google has almost like 5-stage interview process. Although I worked for Microsoft almost 3.5 years, almost like that time, but Google, I got offered a position. I went through stage 4, if I can recall, of the interview, but at the same time, I was also offered a PhD position, which was funded, and I wanted to pursue research, so I left the job. But that being said, I can give you a common, let's say, what's common among the interviews if you want to be a software engineer at Google or Microsoft, is that in stage 3, which is after the technical programming challenge interview, they often ask you about compilers, questions related to compilers. So if you do not have in-depth knowledge of that, it's very difficult for you to clear those interviews. And that being said, again, not all of you aspire to go work as a software engineer at Google or Microsoft or Amazon or Facebook in these top companies. But if you do aspire, then this will be a module which will help you greatly. And this module will also help you in future if you do want to go for higher education like master's or PhD, depending on what exact topic you want to pursue research or higher education on. So in that sense, obviously, compiler is one of the fundamental knowledge that is needed as a software engineer in today's world. Hope that answers it. So I will mark the question. Okay, there are a few more questions. Okay, first of all, this is by Curtis. Good to see that someone is not asking the question as anonymous. So when would a company actually need you to create your own compiler? What I'm asking is, how useful is a skill in the industry? Well, company wouldn't ask you to create your own compiler, again, depending on which group you are joining. So if you're joining Facebook, you already know over the years, although Facebook is now called Meta, but Facebook, regardless of starting as a social media company, they have created their own languages as well as a compiler and platform as well. You might know it as React Native. You might also know that React is also a collaborative framework, language framework developed by Facebook as well. Google has created their own language called Dart. and their own platform called Flutter to develop mobile application. So if you think that companies, big companies, are not asking you to create compiler, that is not true. So there are several languages which are being developed by different companies, and also Microsoft C#. They have came up, made C# now open source. You can develop C# on different platforms, not just on Windows, but on Linux and Mac as well. So if you do not know how to design a compiler, then it's very difficult to get in those teams as a software engineer. I hope that helps. These are some of the example, and we will be going through some of the example through today's lecture as well. So let's not jump very much into the future. We will go through all of these in today's lecture itself, like how understanding compiler and designing your own language is useful. Wow, there are so many questions. I'm out of breath. Let me catch a breath. Okay, thank you so much. So another question, I'm interested in low-level programming. Do you think this module will help? This module will very much help, because I myself is actually, I'm known in the domain of embedded machine learning, which is machine learning in embedded system. So if you do not have the understanding of low-level programming, well, it makes it difficult to work in that domain, because you have to know how to optimize your code in order to make it run successfully in computing resource limited or constrained hardware, such as microcontroller, robots, etc. So hope that makes sense. Let me mark this question. Okay, is it possible to get above 90 in this module? Yes, last year a couple of people have got 90, but that being said, a couple of people also got 10 as well out of 100. So again, it was very varied. If you put in the effort, see, the lectures for this is not very animated. It's boring because we often work or understand concept like automata or how to parse. These doesn't have places where I can animate stuff and make it more interesting for you. So some of bits of the lecture could be dry, but don't let it discourage you from not learning it on your own. Again, some people has got over 90 last year. So, and while I was out like on the street, one of the students came and said, hey, Somdeep, was really glad that we took this module. So that is absolutely possible. And he is now doing his master's in mobile computing, I think. So embedded systems, and it did really help him. So there are a couple of people who did get good score in this module last year. And I hope to see the same from you guys as well. Okay, it is wonderful to hear these insights about big companies. Will you continue sharing them when you are talking about the related subjects? Absolutely. And not just that, I have industry connection as well. If you do end up doing good in this module, and if you do aspire to go in any of these companies, just let me know. I would be happy to recommend you guys as well. So again, I hope to see you guys do amazing stuff throughout this module. And if you need help in any way, I'm there. And the GTA and GLA is also there, but especially I'm talking about if you do aspire to go work for big companies, recommendation letters hold a big weight in getting your foot inside the door, as they call it. And I would be happy to help with that. Okay, another question. So right now, this is the last question for now, and we have to continue with the lecture. So embedded systems are really interesting. I mean, somebody has to think about a phone switch in Bogota. What is expected to work around 20 years without a problem. Sorry, which is there a question? I didn't get it. So I can give you one example. I am one of the co-inventors or co-developer of the machine learning algorithm that is powering all the Samsung mobile wearable as well as tablet devices and also phablet devices. So that machine learning algorithm optimizes or prolongs the battery life of your Samsung device. So if there is any Samsung user among you, you are using my invention right now. So the machine learning algorithm optimizes the battery consumption of your device as well as improves the performance over time. So again, that was only possible because I have expertise in understanding how to work with mobiles and like embedded systems in general. So that is a door open for you in future. Again, if you want to get to know more of my work, you can go to Google, search for my name, and you will get plethora of work that I have done over the years. If anything interests you, get in touch with me. Okay, how many hours a day were you coding back in the university? Okay, here's one thing. So I went to take my bachelor's in computer science when I was 18. I did not do any programming before that. And in our bachelor, the first day in the lab of programming was C. So we started with C, no Python, like many of you fortunate people these days. At that time, so I had no programming experience prior hand, went to the lecture, the lab. The first lab was the introductory, of course, Hello World program that you have to write in C. If you have programmed in C, you already know that Hello World can be written in 5 lines. Well, if you write code like Dennis Ritchie, you can actually write in 4 lines of code, including the include like libraries, STD libraries. So 4 lines of code. I compiled so every one of my fellow student were able to do it successfully because they have done some programming in advance, but I haven't. I ran my code in 4 lines of code. I got more than 30 compilers and I became the laughing stock of the class at that time. Well, that kind of fired me up a lot is because I felt embarrassed, a bit humiliated by my own programming. But since then, every day I went to the lab, even if there was no lab session, I went in and I programmed on my own to get a better understanding of how to code in C. And henceforth learned many more languages. Not just that, actually in the second year of my undergraduate study, I improved so much that I was offered the position at Microsoft as a mobile developer, mobile app developer, and also was selected as a Microsoft student partner at the same time. Not just that, by the end of 3 years of my bachelor's, I published, I think, 28 research papers. And one of them went on to create its own industry. Although at that time, most of my work was related to information security. And the industry that I created was to stop fake degree certificate generation by embedding student information in QR code. That was one of my work when I did during my undergraduate study. I used to code almost 10 to 12 hours a day during my undergraduate study because I wasn't fortunate enough to have prior experience in programming back then. So I had to work harder than my peers just to like move ahead of the curve. That's what I did. I can't expect each and every one of you to go through the same. But again, hard work does pay off in the long run. That's all I can say from this anecdote. And I'm a living example of this. Okay, hope that makes sense. Again, I am closing the Q&A, closing in the sense I'm not going to monitor the Q&A for some time because we still have to go through the lecture. So let me continue with that. Okay. Let me quickly also check the chat as well. Excuse me. Well, someone said battery life is still not so good for Samsung. I don't know which Samsung phone you use. So the S devices has far more battery capacity than your iPhone. That's the popular comparison. But again, these are still out for debate. And well, we can only see the industry standard and compare based on that. So continuing with the assessment, now, mainly you have to keep in mind three things. You have 2 assignments and 1 final examination that you need to give during the summer. The 2 assignments which are already now open, if you go to Moodle, you can look into them, start on your own if you want to, but we will be going through it during the lab on Monday next week. So your first assignment is due on Phaser on 1st of March. The total worth of this assignment is 15% of the total module. And the second assignment is due on 15th of March. The first assignment is due on 1st of March, and the second assignment is due on 15th of March. And the second assignment is worth 25% of the module. Now, the first assignment is more like you have to define and create your own language. And the second assignment, you have to create your own simple compiler, which will be partially based on the language that you have created in the first assignment. So you can reuse many parts from your first assignment itself. Do keep in mind that you only get 14 days between the submission of the first assignment and the submission of the second assignment. So you do have to pace yourself so that you can complete them successfully. Last year, again, another thing that happened, somehow school office did end up putting the assignment submission close by with your other modules. So many students also did not submit anything in the assignment too. And you end up losing 25% of the module itself. So that brings your marks down. But if you start early, then you can pace yourself. And this year, the school office has actually provided you ample of time in comparison with your other modules so that you don't feel pressured. So do keep these in mind. And the final examination is worth 60% of your total module, which will happen in the summer term. Now, the resources that you will mostly be using is firstly, the most important one is the Dragon book, which you will again find on Moodle as well. This book is mainly used for theoretical understanding of the module itself. So if you want to read more on a particular concept, this book will be very handy. The second book that is recommended is the Antler book, or the Definitive Antler Reference book. Now, the Antler book, again, you will also find this reference in Moodle under the resources and books section of the module. And this one will mainly be used for your labs and assignments. Another book that you can refer to is the Modern Compiler implementation in Java. Now, this book is mainly used for front-end and practical example of how to design your own language and how to design your own compilers. So this will be very handy as a reference book as well. Now, some people has initially asked, like, why would a software engineer need to develop their own language? Let's take this example. As you already know, that almost a decade ago, a little over a decade ago, when Android came into play, we already had Apple, its own iPhone, which used to like be written on Objective-C, which was developed by Apple themselves. But then Google came up with Android, where we saw boost in app development. But again, Apple has their own ecosystem of developing apps for iOS, and Google and Android has their own ecosystem of creating apps for on Android itself. But right now, there are companies which need to develop apps for both the platform. They can't just have it for one or the other in order to capture the marketplace. So one of the biggest issue that happened, that you then need to hire more developers only specifically for iOS or Android itself to create app for these specific platforms, which wasn't feasible because hiring more developers also mean that it increases the cost for the company itself, especially in the startup space. And small companies who want to create languages for both the platform, then you need to develop a language or a framework that could accommodate for both the platforms, iOS and Android. So Google developed its own language called Dart, which is very similar to C, Java, C#, Python, JavaScript, all merged in together. So if you have worked with any of these languages, you will find that you can feel right at home with Dart. But Dart has its own like language specific syntaxes that is very handy and helps you develop code with the Dart. And Dart is used by the framework called Flutter, which is also developed recently by Google. Using Dart and Flutter, you can create or develop app for both iOS and Android without the need of developing native code for each of these platforms separately. So as you already know, this module will help you to create your own simple compiler and language. Now, of course, you might not be developing something as innovative or as like groundbreaking as Dart, but at least this module will give you an understanding of how to approach in designing your own compiler. Now, the learning outcome is, well, first of all, before going into the learning outcome, most of you might not be aware of these terms, but do not panic. As we progress along the lectures over the week, you will go through each of these learning outcome and we will learn them. But this is just to give you a rough idea of what is coming over the weeks. So first one will be to demonstrate an understanding of formal languages, how to define them and what are they called, different types, so on. Second is to describe formal languages using BNF or Backus-Naur form, which is very popular in understanding and defining your own languages itself. Now, the third one is explain the link between finite state automata and regular expression, which we will be going through. You have learned finite state automata in year 1 in CE161, Fundamentals of Digital System, but now we will be exploring them in in details, and we'll be connecting the dot between state automata and regular expressions as well. The fourth learning outcome is describe the syntax and semantics of basic programming language elements. The fifth is demonstrate an understanding of the structure of compilers and their main components. And the sixth learning outcome is implement key part of a compiler for a simple language. Now, the lectures are as follows that we will be going through. As you can see, today's lecture is introduction to formal languages and what is languages and compiler and different parts of it. We will be introducing them. Then the next lectures will consist of regular and context-free grammar, back-as nor form, and how to convert regular expression or language into back-as nor form. We will also be exploring finite state automata. We will be introducing the concept of compiler and different parts of it. We will also going through syntax and semantic of basic programming language elements. We will be also understanding lexical analysis of language and understanding parsing. And then we will also be learning static semantic analysis as well as code generation. Now, again, if you do not understand most of it, do not panic. We will be going through in different lectures as we progress through the module. So, an overview. So our primary focus will be on the conceptual and practical issues related to compilers. Especially, we will be focusing on front-end. Now, compiler traditionally can be thought of like it has two parts, front-end and back-end. On the front-end side, we will be exploring concepts like lexicon analysis, parsing, semantic analysis and types, and also translation for code generation. So these mostly consist in the front end of a compiler, and our majority of the module will be focused on that. Now, on the practical side, we will develop an expression analyzer for the language, programming language, and we will also develop a compiler for a small language that you will develop as part of assignment 2. So labs and assignment, most of the lab time will actually be consumed like for you to it will be devoted for you to work on the assignment itself. But in order to progress through the assignment, you need to understand some of the basic that you will be doing with Java and Antler that we will explain during the lab next week. But again, as we progress along the lab, most of the time you will be spending on the assignment, but some of the time will be assigned to learning how to use Antler with Java in order to do lexical analysis and parsing successfully, so that you can build your own simple language and extend that to building your own simple compiler as well. Now, some of you may find this moderately demanding. So my suggestion would be better to start early than leave everything till the last minute, especially the second assignment, as I have already mentioned. In principle, you should be good in exercising designing and writing modular program in Java. But again, if you do not have much experience with Java, do take separate courses on Java itself. If you need resources on Java, I can post them on Moodle so that you can take separate courses on them, and that can greatly benefit you through the lab. Now, lectures and reading. Oftentimes, student has an expectation that everything will be covered in the lecture, but this is not humanly possible. We only have till academic week 25 to cover languages and compiler, and it's a huge topic. It's a like subfield of computer science and one of the basic fundamental topics of computer science itself. So lecture should be seen as more like a guide to the material that you will be reading on your own. So again, it's not possible to cover everything, but we will be covering the main topics that you can expect to see in the final exam as well. So the lectures will be more like a guide, but again, we wouldn't ask you questions which we haven't covered during the lecture. So do come for the lectures, as you will learn greatly from it. Now, again, additional reading you do have to take on your own time to get a more holistic picture of the topic itself on the languages and compiler. And acknowledgement to Dr. Chris Fox and Dr. Andre Mahidan for contributing to the content of the module, as they were like initially used to be associated with the module, but again, like since a couple of years, they have moved on to do something else. But thanks to them, who has greatly shaped the module over the years. Now, the most important question, what if you do need help, right? I'm always available. Do send me email, but I would say oftentimes you end up asking question, which is very common and also being asked by other students as well in the course. So I would suggest that use the chat forum in Moodle, which you can access through this link, or shortly I will also be showing you how to access these resources on Moodle. So do post your question on Moodle if it is more on the generic side, or particularly on a topic on the languages and compiler. If you have a personal question or specific question that relates only to you, you can send an email to me at somdeep.day@sx.ac.uk, or you can also come to my academic support, or you can also email our GLA GTA Amirul at his email as well. Now, before we go into the brief history of languages, I want to quickly show you the Moodle. So can someone confirm that you can see my Moodle? Okay, thank you so much, Barak. Again, so thank you so much for confirming. So let's go through this. As you can see here, you have welcome and support. If you go inside that, it tells give information about me, which you can also, me and our GLA and GTA, which you can also find on the right hand side of the module as well. Here you can access the announcements. The announcement will be specifically if I need to announce something like specific related to the module, then I will be doing that through announcement. Or I also like personally prefer to use the help forum, which is the chat forum, where you can post question, as I've already mentioned, or we can, like, if I have to share any resource, I will be doing that in the help chat forum itself. Module information, you can find it in this section. I have also created a separate section, which is the chat forum, which is the same link to that chat forum, the announcement and the chat forum itself. Oftentimes, you guys do not end up using this, but do use this because this engages with your peers or your fellow student. But at the same time, you can share resources, or you can ask questions which can be also shared with everyone else, not just one specific person. So do end up using this because it's one of the best way to learn through the module as well, apart from the lecture and your personal reading. The assessment information, it's already open. Again, the breakdown is already given here, and you can already access the assessments and the assignment from here, not the, of course, the final examination, but the assignments are already open for you. One thing I would also like to mention that I have also provided that guideline that you can use, and it will greatly benefit you to tackle the each assignment and how to proceed with your assignment. You also have some FAQ on the assignment 2 as well, because oftentimes students find it difficult on the assignment 2, but we have chat forum. We have made the assignment very like self-explanatory. In case if something is not self-explanatory, we have also provided specific question in the FAQ, question and answer, to help you understand what you actually need to do in the assignment itself. Again, books, if you need to get resources on that, you can click on the section of the books. All these stuff are already provided, that the books that I have already mentioned. You can access them easily from here and learn on your own time. And Antler, so we will be using Antler. Antler is a framework which can be used as a plugin with your Java for lexical analysis and parsing. You will be using Antler with your Java programming to help you with your assignments as well. So resources on Antler will be provided here, and it's already, like you can see when you go there, you can find all the resources that you need for the Antler. Now, as we proceed, each week the unit, the lecture, PowerPoint, as well as the recorded lecture will also be made available for you to access at a later time on your own pace, at your own pace. So as we progress, each section of the lecture will be unlocked. Now, let's quickly look at some of the Q&A. The books are around 10 years old. Are they still relevant? Yes, the basic structure of compiler has not changed. New programming languages and compiler has been developed in recent years, and it is still being developed. Even last year, new languages and compilers came out. But one thing you have to keep in mind, that the concept of this module is not about new innovation, because truly, although new compilers has been developed, but if you look into the core structure of a compiler, that has not changed since like 1957, since the development of Fortran programming language. And we will also be covering those today shortly in the brief history. But again, the basic structure of compilers has not changed, although innovation has happened in different sections, but the structures has remained the same. So the books, even if they are 10 years old, they're absolutely completely relevant for your study. Do you recommend Crafting Interpreter by Robert Nestrom? Well, you can definitely like use that as a reference, but again, crafting interpreters. So interpreters are a bit different from compilers, how they process programming languages. So crafting interpreters is mostly related to interpreters itself, not so as to compilers. They do such touch some of the concept as compilers, but again, like if you want to read, you can, but you can optimize your own time to read on compilers and get a better grade on this module. So again, it completely depends on your time, how much time you have in your hand. If you want to read on interpreters, do go ahead with that. But again, this module is mostly focused on compilers. So I think that says it all. Okay, will lab material be published on Moodle? Yes, they will be published during the lab. So right before the lab on Monday next week. So do not panic. They will be made available as we go along. Okay. Now, before moving into the brief history of languages, let's quickly take a 5-minute break, grab drinks or like whatever you need to take a break, like in the 5 minutes, whatever you need to do, go ahead with that, excuse me. And we will resume the lecture in 5 minutes, okay? Okay, will you provide answer for the lab material? So yes, the lab material already tells you what exactly you need to do. Those will be provided with the lab. Do not panic. It even tells you the step-by-step process of how to set up Antler with Java, how to do something. Solutions are already provided. They will be made available during the lab from first day. So you can work at your own pace on your own time. Do not worry about that. Those will be made available. It's just that now I do not want to overwhelm you with a lot of things. That's why lab isn't available yet. But as we go through the first lab, we will demonstrate you a couple of things that you need to know, and then the resources will be made available to you. Okay. Let's take a 5-minute break. We will resume like shortly. Right now it's like 3:58 in UK time. So let's come back at around 4:05. So 4:05, and we will resume the lecture. I will pause the recording for now about this because this one is very important. So again, I'm going to repeat the question. Do we have to use Antler for the expression analyzer and parsing as well? Or whether you can do without? Of course, you can write your own program to do without Antler as well. But the issue is, do you have time to build that program as well? Antler is already developed for almost like 20 years now, almost 2 decades, very sophisticated, and it does the job for you. So in order to create tokens, define the grammar, Antler will help you greatly during the lab. Do use it so that it makes it easier for you to mostly focus on the definition of the language and how to define the language, rather than worrying about, okay, how can I do form lexical analysis on your language? How can I parse? How can I create semantic tree? So those headaches are already like offshored onto Antler. So do use Antler. It will help you. That's why we mention it, so that you can focus on what's actually needed for you, rather than again developing a separate program to do the job, which Antler does it easily. Okay, enough for question. Let me share my screen. Can you see my slide on brief history of languages? Can someone? Okay, perfect. Thank you so much, guys. Excuse me. Let's look at how languages have developed over the years. So programming languages basically or traditionally can be thought into 2 parts. So you have high-level languages and you have low-level languages. The high-level languages are more like the programs that you create are easy for programmers to write and reason with. Example is like C, C++, C#, Java. The program that you create using these languages are high level because it's easier to understand. On the other hand, you have the low level languages where the generated code is more close to what can be interpreted directly by the hardware. Now, during the 1960s, when programming languages and compiler concept of compiler was kind of being developed, the low-level languages are kind of bit separate from machine code itself. So low-level languages were programs or codes that were closer to be interpreted by hardware, but machine code was completely the code that could be directly run on the machine, and it was hardware specific. But in the modern day, low-level languages and machine code are kind of intertwined and almost could be thought in the same level. But they do have their own differences, as I've already mentioned. Now, implementing programming languages, traditionally there's like two strategies. First is interpreter-based, and the second one is compiler-based. The interpreter-based is where the program runs the program during the runtime. So no compilation or type checking, error checking is performed while the code is being like compiled itself. So in the interpreter, when you run the program, everything happens on the runtime. And if there is an error, like type checking error or error of another form, then interpreter throws it based on that. So interpreter goes through each line of code and interprets them for them to be executed. So it's harder to pinpoint if there is any error while you're writing the code. On the other hand, you have the second strategy, which is the compiler base, where the program translates your written program into machine code. And doing so, it makes it far more easier to track the errors or type checks that could happen in your program. And at the same time, compiler also like makes it easier to optimize your code for hardware specific devices. So you can run your code, like you can write your code in one language, but you can run them on plethora of devices having different types of hardware. Compiler is better for in that sense. But now we have the modern approach, which is more like hybrid, where you use the concept of interpreter and compiler together intertwined. What does it mean? So again, the compiler is specific, like examples could be C, C++, C#. These are like compiler based. But when we move towards the modern programming languages, they are more on the hardware level, hybrid level, where compilers produces the virtual machine code that is used by the bytecode interpreter, and the bytecode interpreter then execute it just in time, like on the system that it is being executed. So modern is more like, modern programming languages are a hybrid of interpreter and compiler. But in this module, we will be mostly focusing on the compiler on its own. So going back, this is even before my time, like even I wasn't born back then. So this is like 1940s, where programs, in order to make a computer do something, you cannot write programs like as we do today. You have to like take cards, specific cards, and punch holes in them. The pattern of the hole, actually, when you put the punch card like in the computer, the pattern of the holes on the like punch card signifies electronic signal in the computer itself. So you can understand, if you have to write a new program, you always have to change the punch card. And you also have to like punch cards specifically. If there's a mistake, you have to redo it. And this kind of greatly like reduced productivity. And it used to take long time to make a computer do something specific. And after the like hardware, like the punch card handling computing system, we had evolved to stored program machine, where, so as you can see, let's define these couple of stuff. So we have the machine code that we have already mentioned. So machine code is mostly, you will see, is written in binary. And it feels like if you are very good with binary, then it's absolutely fine. But also writing code in binary is painstaking, like it takes a long time. Then you have the assembly code, where it is more like intuitive because it's more English like. As you can see the code here, which is load #2, it means it loads the value 2 in the accumulator. Now, what is an accumulator? Accumulator is a specific type of register on the hardware that is used to store logic. So you can see when from the hardware, like hardwired programming like punch card, when it evolved to stored program, like now you can store your code in the registers or accumulators of the hardware in order to execute them. But still they weren't efficient because productivity were still very low. So in order to program the computer to do something specific, it would take much longer. By the way, we have something in chat. Let's see. I studied assembly language this summer. You have to write 30 lines to print a statement. Yep, Burak, absolutely correct. That is like, just to print a statement, you have to write a lot of lines of code. And it also depends on the hardware itself. So if you change your hardware, even your assembly language also changes. It's not productive at all. So moving on. So then in 1953, we can see IBM developed the 701 system, where all the programming is done in assembly. Has the person has already mentioned how painstaking it is these days to even code. And imagine at that time, they had no other ways to do it. So like coding in assembly, this development of software cost was more than the hardware cost, because you had to employ more developers, software developers, to write a piece of code, because it used to take more time, more lines, and they need to have specific knowledge on the hardware itself. Then it wasn't that feasible. Here enters the scene is John Backus, who was like a really famous scientist. He introduced the concept of speed coding. So speed coding was the first high-level programming language back then. Although right now, if we see, we still might feel it more like a low-level language to some sense. But at that time, it was considered as a high-level language because it was more expressive comparatively, compared to assembly level language and machine code. And with the introduction of speed coding, the interpreter, although it improved productivity of a software developer, but still there were differences between the high level programming language optimization to the low level programming language. And the interpreter used to take almost 10 to 20 times slower than the native machine level code to run. So although it was productive for software developers, but it wasn't productive in as a whole, because it would take longer to execute the program. So example of machine code, as we have already noticed with the machine code and the assembly code. So you have to define something like this, like a combination of binary and hexadecimal in order to just do something. It's already there in front of you. I don't want to go through each and every line, but you can see how difficult it is to code using machine code. Again, this is another example of hello world in assembly. Remember, in C programming, including your libraries, standard libraries, it's 4 lines of code. But as you can see, in assembly language, it's so many lines. So it's not really productive for a software developer to write an assembly level language, because it takes longer to code. Now, the biggest innovation in programming languages and compiler happened was when Fortran was introduced. So Fortran was again a language which was introduced by John Backus in between the period of 1954 and 1957. And this also introduced the concept of compiler as well. So it completely revolutionized the idea of software development or program development back then. It can convert high-level languages, like which is the Fortran it is. So you write the code, and then it converts to the assembly level language. And it used to be called, and it's still called, the automatic programming. It's because like it used to convert high level from low level and machine code on its own. It was wildly successful, and like language was used in different ways by computer programmers as well as scientists around the world. Scientists in the sense, if they used to or they still work on physics, chemistry, biological sciences, many scientists still today use Fortran. So if have you heard of CERN, where we have the Large Hadron Collider? So at CERN, we use the concept of HPC, or like high performance computing, in order to do simulation. And at CERN, people still use Fortran as well. Now, that being said, although it was developed back in 1954, around that time period, I did my master's in computer systems engineering from the University of Manchester back in 2014. And I also programmed in Fortran as part of my master's project. Now, I was fortunate enough at that time, the fastest supercomputer in the world was RICEN supercomputer. And my project was to work on that supercomputer. And I have worked on this Fortran, so I can say that it's not a dinosaur yet. So this programming language is still used even like 70 years, 80 years like now, since it's being conceptualized. So it has been so popular because it provided the fundamentals of programming as well as compiler system. Now, after Fortran, we can see a lot of languages come up, such as Lisp, Algol 60, COBOL. Out of this, Lisp is still used today as well. It's a symbolic, like dynamic data structure based language, but Algol 60 and COBOL are not that used that much anymore, because Algol 60 and COBOL, they are like succeeded by far more like high-level languages such as C, C++ that you know today. Now, around the 60s and 70s, especially in the 70s, we call it the language explosion. We can see new concepts of programming language come up, even if you have worked with C++ and Java, where you use object-oriented programming. So it was introduced, the concept of object-oriented programming, through the language called Simula 67. And like it was like the stepping stone to something far better and bigger, which you know, C++, C#, Java, as we know today, and even more modern language, Dart. So these are all using object-oriented concepts. 1970s, as I've already mentioned, a lot of development has happened. You can go through this like on your own time. Now, moving into the present, this is where we kind of need to focus, because this is where we will be mostly working on. So over the decades, complexity of languages increase, but with complexity, even features that you can implement in a language also increased as well. Example is C++, C#, later versions of Java. You can do much more than 20 years ago when these languages were introduced. So today you can have more features especially let's say if you're working with C# and Java, you have a list that wasn't there 20 years ago when these languages came out, but today you have them. So these are some of the like amazing evolution that happened over the decades. Now, we can also see that over the decades, as new form of computing system came into existence, new languages were also developed, especially with the development of World Wide Web, or as we call it, the internet, right? So we can see specific programmer needed a language that can improve their productivity to create website or web applications. Then we can see languages such as HTML, PHP, Perl, Python came into existence. So you can see from here, it's like a hint or a tip that languages, programming languages are created specific to a community of programmers and also for a targeted computing system. So over the year, you can also see like we have a lot of different type of languages with different complexities, such as Go, Rust. You have already some of you might have used Go by Google. It's one of the fastest languages that you can find today, apart from C itself. And we also see the introduction of new concepts such as garbage collection in the languages. Now, if some of you do not know what is garbage collection, it's more like when we were storing and writing program, we could notice that oftentimes if parts of the code or snippet of the code are being reused, variables are being reinitialized, then that can on the memory can hold garbage value or like gibberish value, which can lead to unexpected behavior of your code. So we can see the introduction of concepts such as garbage collection, which makes it easier to handle this issue. Now, we have two more questions. Let's go through them first. What do you think about no-code movement? Well, it greatly improves productivity, especially in the entrepreneurial world, because even if you do not have prior experience in coding, you can still build something as a prototype to show to the customer. So we call that creating the MVP or minimum viable product. But that being said, you still, after you have launched your prototype or MVP for your customer to use, you will see that you hit a barrier where you can't develop more features because no code environment still do not provide you the flexibility of introducing features that are not within that domain. So if you want to code like something really cool, which has a lot of features, then you might have to go into native coding itself. What is your favorite language? It's very difficult to say because I still code like a day-to-day using C and Python very much. But over the years, I have worked on every single language. As also would like to mention that my latest project, the Nosh app, is built completely on Dart and Flutter. So I regularly program using C, Python, Dart. But let's say if you do tell me, hey, I have a project in mind and I want to build a prototype, I think I will be more inclined to developing in Python. But that's again, it's a personal choice. It's just because Python comes with so many libraries and so much community support that it's faster for me personally to develop a program in Python. But again, it depends. It varies on the computing system or the app that you are developing and what language you are comfortable developing in. Another question, can you explain interpreter again? Okay, yes, interpreter. Imagine this. you write, so Python is an interpreted language. Where you write a program, you can see there is no compilation button. You just run the program. The interpreter, interpreter can be thought itself as a program. The specific purpose of the interpreter program is to go through each line of code while it is being executed and do type checking, error checking, such as, let's say, if you have denoted a variable, it assigns the type of the variable on the runtime, as you know in Python. So it's dynamic. All these things happen while the interpreter goes through each line of your code and execute them. So let's say if you have an error in if you have 1,000 line of code in your program, and your error is in let's say line 700. So it will execute the first 699 lines of code, and it will catch the error in the 700th line, which is not efficient because you're losing out time while executing. Whereas on the compiler, it has far more optimization going on behind the scene. And we will be going through that as we progress along the module itself. Hope that helped understanding what is interpreter based programming and slide like the basic difference between interpreter and compiler. Okay, one last question for now. What are your opinion on MicroPython and Cython for embedded systems application? Well, again, opinion in which way? It's a broad topic. Embedded system itself is a broad topic. You have embedded system which such as Jetstone, which comes with far more like powerful computing resources such as CPU, GPU, RAM on board. So that is also an embedded system. In comparison, you have microcontroller, which only has few register. It doesn't even have memory. So using MicroPython on different platforms would vary and how you use it. So again, it has to be more specific. Embedded systems itself is a subtopic of computer science. So it's very broad. You have different type of computing systems with it. Okay, moving on. Let's take a look into how sorting. So this is an example of how sorting is performed in the 4 different languages: Fortran, Algol 60, APL, and Prolog. Now this is just to show you that even a simple like sorting could deeply, like the programming, the code behind it could vary a lot from for each of these programming languages. And this also shows you that depending on the task in hand, which is your app or software that you're developing, you need to choose your programming language carefully. Okay, before we proceed, I will also give you one example from my project. So we had to debate almost like for 2 weeks among the team to choose which programming language and framework we are going to use to develop the Nosh app for both Android and iOS. Because there are many, you have Xamarin Forms by Microsoft, using which you can create apps for both iOS and Android. You have React Native by Facebook. You can create apps for both iOS and Android. You have Dart, Flutter by Google, same. But again, you have to choose the programming language based on the need of the project, also based on who are the developers who are coding in the project, and what type of community support you get on your programming. Because let's say if it's a language, you start developing a software, and if you are stuck somewhere, there is no one else to help you. So how do you proceed? You can't. So you have to, for a specific software project, you have to choose your programming language very carefully. Now, moving on to seeing these example of sorting for different languages. I won't be going through each and every line of code, but this is just to show you how the structure of the code could greatly vary, and also the how many lines of code are being written from one language to the other. So this is an example for Fortran. Keep the structure in mind, because if you compare with Algol 60, you can see Algol 60, it can be done in far shorter lines. But again, you have to know the syntaxes for Algol 60. This is an APL, the shortest out of these examples. So only 2 lines, done. And this is in Prolog. This is also one of the shorter form of like among the Fortran, Algol 60, APL, and Prolog itself. So you can see just a simple sorting. Writing the program for it could vary so much depending on programs. Now, when developing languages, what are the problems that need to be addressed? So the problems or the issue that need to be addressed is how to describe language clearly for programmers, specifically for implementers. As I've already mentioned, giving the example of the NOSH project. Now, the other thing that you need to keep in mind is how to implement the description, and whether to know what you are doing, the implementation and description side is correct or not. You also need to focus on how to test the language, because a language can have a lot of features for modern day programming. But as you develop those features, sorry, it's my automation. Sorry, excuse that. So while you develop your language, you do need to keep in mind that as you introduce more features to the language, you should be able to test those features, and they should be future proof as well, because the language will be used by many developers among your community. Another challenge that you need to keep in mind is how to save the implementation effort, because with multiple languages, you can target multiple computing system or hardware. So can you reuse some of the parts of your implementation and extend it? So you do have to keep this in mind as well. Another thing that you need to keep in mind is how to make languages usable. If you have worked with C# or Java, they have different versions coming up in a couple of years, right? So the core concept of Java, C# are still remaining the same, but as more features and computing system supports are added, you can see the majority of the part of the languages are being reused and iterated as they evolved over the years. So this is also something you need to keep in mind while developing your own language. Now, let's look into the compilation stages. So compiler, as I've already mentioned, has 2 specific parts, the front end and the back end. In the front end, when you have the program, you have the source code or the source program, which is then processed through lexical analysis, and token streams are created. Now, token streams are specifically like words. Now, we will be going in details in next lectures, but imagine our English language. It's a language, but English language consists of word which develops a sentence, and the sentence gives you a meaning, or it has semantic or logic behind it, right? So in the languages are built by words, which is also called the token, and the token forms the sentences. So when you write your source program, they are processed by the lexical analysis in the front end of the compiler, and tokens are generated the same way as English language. Then the tokens are processed using a term called parsing. The job of parsing is to create a syntax tree. It could be concrete syntax tree or abstract syntax tree, but the syntax tree provide you a way to understand what is the logic that is trying to be built. Then the syntax tree is being processed further, called using static semantic analysis, and then an annotated syntax tree or an optimized syntax tree is generated. The optimized syntax tree is then further optimized to create more optimization, and through the optimized syntax optimized tree, further code generation happens, which creates virtual code that could be run on specific platforms or computing system. Now, when the virtual code is generated, we move on to the back end of the compiler. In the back end, the steps that happen is the virtual code goes through the process of code generation, and real machine code is generated based on the hardware. The real machine code is then further optimized through optimization process, and optimized machine code is created. And then we have another part of the compiler, it's called the linker, because even if you write your own high-level program, which is being translated through the different stages of the compiler, and you have the optimized machine code, but your high-level code can still be dependent on other libraries and packages that can be used in order to achieve the desired result of your program itself. So the linker of compiler do those linking to other object code and library code with the optimized machine code. And after the linking is done, then an executable is generated. The executable is then can be executed on that specific hardware, and you get the final output of your program. Now, let's summarize the general structure. So a sequence of translation that happen at its stages, it's mostly to filter out the errors or remove or put aside extraneous information that is not needed, because at high level you can write a lot of code, but in the hardware level, when you run the code, it has to be optimized, and it has to be, because your, let's say, depending on the hardware, like processing unit or processing element that you're using, it comes with limited number of registers and memory. So the program has to be optimized, and in order to optimize the program, you have to remove or put aside extraneous information of the code. And also to make data more conveniently accessible on the memory for it to be processed by the processing elements of the hardware. The final target is to produce an equivalent optimized program that can be executed by the intended machine that you are targeting. Now, one strategy to keep in mind that use the tools that partially automate this procedure. So Antler is a really great example of that. Antler helps you automating the lexical analysis and parsing side of the compiler. So you can get access directly to the syntax tree, and you can reuse the syntax tree to do your further compiler development. Now, again, summary of the stages that we have already went through. The lexical analysis, where we recognize the words from your programming language, or formal languages, and the words can be divided into several words, or as we call it, tokens. So here you can see with an example, if we have an if statement that if x equal y, then as it goes. So here, if x equal, these are all tokens that are accepted by this specific programming language. Then after lexical analysis, we have the parsing, where we identify the sentences using these tokens from the program, and we produce a syntax structure. We call it as syntax tree. And then we have static semantic analysis, where once you pass through your tokens, we then check the program whether it is meaningful or not. Full analysis of meaning is often complex. So compilers perform conservative analysis to check consistency. And what do I mean by this? The compiler checks for, let's say, type checking, if the data type are matching or not in your program, or the items are defined, or items means variables are defined before they are being used. You must have come across while writing issues, while writing program, that it has said that, oh, you have not declared this variable, please declare it, right? Especially if you have worked with C, C++. So these are done by the compiler as well. And then after the semantic analysis, we have the optimization side, where the program needs to be more efficient. And efficient in terms of it has to be smaller and execute faster on the hardware system. And also remove any redundancy that is not required, because hardware system still comes with limited computing resources. And the next stage is the code generation, where the code is translated into machine code or intermediate language. And it can be thought similar to the translating between human languages, which have different words and grammar. So if I speak in English and someone else speaks in Spanish, we still have to do the conversion. Like we have to translate English to Spanish for my Spanish friend to understand what I'm trying to say, and vice versa as well. So code generation could be thought as the same for the compiler, where your program can be translated into code that could be understood by the machine. Now, one important stage that we need to keep in mind is the intermediate languages. In intermediate languages, like there are typically two code generation steps that happen. You have the abstract general purpose intermediate language, which is more close towards the low level language. And then from there, from the abstract intermediate language, a more target specific, like hardware target specific machine code or language is created. So as they progress from the abstract to the more abstract, which is the machine instruction. So that's what intermediate languages signify in this sense. A full-fledged compiler will typically perform optimization both before and after code generation as well. So lower levels of the code expresses more specific information for the specific hardware that the code is being executed. In this step, you have to keep in mind the lower level expresses mostly for, let's say, registers or the memory layout that needs to be specified. The different representation of program makes it easier to express, identify, and implement different kinds of optimizations as well. Now, the issues that you are going to face or that you are going to see. And do keep in mind as well that there are many pitfalls in compiler design, such as how to handle program errors, because error can happen in different ways. So you have to, when you design your own compiler and design your own language for the compiler, you have to keep in mind what specific program errors that your language can support. Now, the design of a language can have a radical impact on how easy it is to build a compiler and also to optimize the generated code. Now, I would like to point out something, that your first assignment is basically to define a language. When you start working on your first assignment, do keep these issues in mind while you define your language. And using in the second assignment, you will be using the definition of the language to further extend it to develop your own compiler. So these issues will be very important and to remember. So it will help you in developing your own language and compiler. So again, these things are some of the basic criteria for a good language design. So do use them as you develop your own language and compiler. And also remember that ease of use of your language and expressiveness of your language is also very important as well. Now, how do compilers have worked in today's generation? So as I have already mentioned earlier in the lecture, that someone says we have the Dragon book is 10 years old. Is it relevant? It's absolutely relevant, because if you still see the core structure, like the front end, the back end and the linking of a compiler, the structure of the compiler itself, that happens even in modern compilers, they have remained almost the same over the decades. So the general structure of compiler has not changed since the Fortran compiler itself. The biggest change is perhaps that right now hardware systems are so varied, and they come with different processing power and also different types of processing element. So based on that, most of the innovation happens in the back end of the compiler, which is like code optimization, intermediate language representation, and those areas. So this is something you have to keep in mind, that the biggest change right now in the modern compilers happen mostly in the back end, but the front end almost remained the same. And this module will mostly be focused on the front end side, although we will be going through the back end, but your assignments are still mostly focused on developing the front end of the compiler. Again, we have already mentioned that computer power has increased, because now we have more cores that could be fit in the same area of the chipset. So more core, more different types of processing element like CPU, GPU, even now we have NPU, neural processing unit, specifically for AI and machine learning execution. All of these come as processing elements on the same area of the chip. This has evolved, and so the intermediate code representation and code optimization has also evolved accordingly. So why so many languages, if some of you might have that question? Now, languages are adopted for a specific need. As I've already mentioned, you have to choose your language carefully. Every language has its own benefit and like pros and also cons. Oftentimes, if you end up working with the evolution of new type of devices, oftentimes a programming language might not work very well with this new type of computing devices. For example, right now, a boom is happening in IoT space, Internet of um, Technology, Internet of Things. So in the IoT space, we can see edge devices such as wearables, smartphones, phablets, tablets. These specifically, when you run certain type of program which is developed by, let's say, languages such as Python, C, C++, it might be efficient in terms of development, but it might not be optimized for the hardware that you are developing. There are many other factors as well which are revolving around this area, such as productivity of the software or what type of software developers are working in these region. So you will see as new type of computing system are being developed, we can also see new type of languages are also coming up. So the basic concept around this is you have to focus on the community of developers that is working in that specific computing device. And based on that, the languages are being created accordingly. One thing you need to keep in mind that it's easy to introduce a new language because it has its own niche or core developers, but oftentimes new languages can also be poorly developed. So you need to keep a balance between these factors as well. So language design criteria for good design are, there's no specific like policy or a constraint, but there are a few things you can keep in mind is that like it should make it easy for the developer to write program that is easy to read and is reliable. It should also make it easy to find and avoid errors. For example, using types and type checking. The language should also have the should allow the programmer to focus on details at an appropriate level, such as reusing functions, using abstract data types, or creating modular code of the program, and so on. High-level languages also allow programmers to ignore irrelevant hardware-specific details as well. So you will be mostly, for your language and compiler, you will be mostly focused on high level as well. So do keep this in mind. Some approaches such as object-oriented programming or address several of these issues that we have already went through the lecture. Do keep in mind, this will help you to write and develop your own language and compiler. So the summary of the whole lecture that we went through is like introduction of new languages. We have covered that, like how did the languages evolve over the new target platforms, and how compilers are still required in order to develop code and build software on top of these. So there are application areas where it is appropriate to develop task-specific languages and language extensions and optimizations as well with the associated tools. Understanding compiler can help you with the understanding of program behavior. And it is also an area in which many fundamental issues in computer science can still be seen in action. So thank you so much. We have reached the end of the lecture. And is there any question that you would like to ask? Are people still awake, or like, did you fall asleep? Can you at least interact in the chat? Okay, perfect. Thank you, Stefan. Is there any question regarding today's content? Perfect. See, this is what I like to hear. People are saying, I am awake and excited to work on my compiler. Yes, that's the enthusiasm you need to do really good in this module, because most of the stuff will be taught, will be provided, like literally we hand it over to you. You just have to modify it in order to build your own language and compiler. See, I should not be saying this because this is on record, we are recorded, but most of the resources will be provided during the module. You just have to understand the concept and implement it as your own. Now, we have a question. How much time do you think it would take to complete the questions if you are amateur in programming? Unfortunately, Tariq, good question, but this is not something like I don't have a crystal ball, because amateur in programming for some people can mean very different thing for other people. But the coursework, like the assignments, we have designed it in such a way that it is completely doable. That is something all that I can mention. So if you start early, don't keep it till like last minute, like last 2 or 3 days, and then finally you realize, oh damn, I have to do my assignment. Of course you're not going to get it down, right? But if you start early, I have provided, if you go into the section on Moodle on the assessment, I've provided you a timeline that you can follow, and that takes you takes a big load out of your head, like, because you know that if you follow that timeline, you will meet the deadline for sure. Okay, another question. So I am impressed and I think we will have a good run together. Perfect. And I look forward to working with all of you. I'm really excited about this module. Okay, another question is, could you release the FAS laboratory this week so I can make more informed decision about keeping the module? So there is no such thing as first laboratory. It will be, from day one, like of the lab on Monday, we will make all the labs available. So labs does not progress as we go. The lectures do, but the thing is, we cannot make it available before Monday because we still have to change it based on every year. And we are still making some changes based on this year's cohorts specialty, so that it's easier for most people to understand and undertake the lab. But I can assure you that if you do have some programming knowledge, especially in Java, it should not be difficult, because we even give you a document where it will say, okay, download this, install this plugin, click on this, use this feature, you will get this. It's in that sense. So unfortunately, the lab will be made available on Monday during our lab session, which is very soon, in a couple of days. But before that, cannot make it available yet. Hope that makes sense. Any more question? All right, we are running a bit late, 7 minutes, but again, will the lecture slide be released before the lecture? Right before the lecture slides will be released. So you can notice that today's lecture slides are released in the morning today. So usually before the lecture, around like in the morning or early afternoon, the lecture slides will be made available to you so that you can download and follow along as I walk through the lecture. Hope that makes sense. Okay, could we come to your office for different issues other than this module? You can definitely, although I would mention that you should already have a personal tutor who is more catered to help you towards those kind of things. But if you do come to me, so office, right now I'm still holding my office hour on Zoom. So if you want to come along on the Zoom session, please come along. often there's a queue as well. So I will let you in as I go through like help each student during my Zoom session. On Moodle, on Moodle I have specified, and also today's lecture I have specified my office hour. So do keep that in check. Do come to me with any problem, and depending on what is the problem, I can direct you to people who might be able to help you further. Hope that helps. So again, if there is no other question, we will be ending today's lecture. Thank you so much. I hope you got a brief understanding of what you're going to get in this module. And I hope you are already, as they call it, pumped up, and look forward to work with you this session, like this term. We have one more question. Would you consider a 15-minute short lesson on how to prepare for interviews? I can definitely do that, which will not be part of this module, but I will do that, let's say, end of this module, like around academic week 25, which is the last week. I can definitely do how to prepare for interviews. I can also do a short presentation on how to pitch. Let's say if any of you are entrepreneurial as well, and instead of going to work for other companies, want to start your own startup and come up with ideas, I can also help you with pitching as well. I can do those lectures, but that will be end of the module, so academic week 25. Hope that helps, and thank you so much, everyone. Do use the chat forum on Moodle if you have more questions, and we will be there to help you out. Okay.